Now that we've talked about sampling and we understand how to get data and put it into our process, we need to think a little bit about how are we actually trying to understand what's different between Bob and Wow. And so what we're going to do is we're going to develop a research hypothesis. So what is a hypothesis? Well, really, there are two types. A research hypothesis is a tentative statement about reality, what it is we're trying to investigate. And so what we're trying to say is that there is some idea we'd like to go through. Now, this is different than a statistical hypothesis. So a statistical hypothesis is a mathematical expression of a test which we're going to be used to determine the confidence level we have in making an estimate of the difference between two alternative choices. And so the research hypothesis you can think of a little bit differently. So, for instance, I usually call this theory O, or theory opinion. The potential causes of theory O could be my opinion, a conjecture, a desire, a wish. Maybe it's a hallucination or a dream. But what we say is, I think this is what's going to happen. It may or may not have any truth, or it may or may not have any engineering basis to it. And so what we want to do is take all of those theory O, or theory opinions, convert them into a logical hypothesis, test them for truth, and understand the risk. Now, in statistical hypothesis testing, we don't actually prove anything. What we do is we eliminate alternatives because we're going to use a principle of falsification, which is a fundamental concept in science. That if we falsify something and we can prove that it's not true, then its logical alternative should be true. And that's worthy of consideration in terms of further analysis. So what we're going to do is try to falsify statements about facts. So how do we go about this? Well, first of all, we've evaluated a process. From that, we get some sort of expectation about hypothesis. This is the research hypothesis. We'll go select the sample of data, and then we'll characterize it. And what we see in this whole process is two things that determine how good this is. Well, we have all of the physical things, understanding the process, choosing the right factors, the X's, understanding the business problem, the quality of the measurement system. That's all from the measure phase. From the analyze phase, what we see is we have to understand how good is the sampling method, and then what's the confidence level we can get from this sample size in terms of the ability of this sample to be able to detect change. Then we can choose the test that we want to have, and then how well do we interpret that test? And that's the characterization of the operations. So, the beginning of our process, what we're going to do is we have a problem. We break that problem down into questions, and they may be causes or questions about particular causes. From that, we'll develop a theory. We think this is what's going to happen for that particular cause, and we may have multiple theories for any particular cause. But each of those theories, we should then define the hypothesis. This is what we think is going to happen, and this is what we think is not going to happen. The thing that's going to happen is the alternative hypothesis. That's what we'd like to reject. And then we prove the alternative, which is maybe not so interesting for us. So we're going to go through, and we want to understand these hypotheses from two perspectives. One is the practical difference in terms of what does it mean to reject that hypothesis, and then what is the statistical significance in terms of the rule by which we reject it based on the adequacy of the data we've observed. So, there are some typical hypotheses, and these are actually based on questions we might have. So in a process, we have inputs going into an activity. We take a test and say, was the output of that activity meeting our decision criteria for goodness? And if it was, we get a good outcome. If it wasn't, we have a feedback loop, and something has to be redone. So the basic questions is this process any different from history? So we'll see that's a one sample t-test. One sample, the process outcome, compared to a criteria, the historical performance. Did a process change make a difference? So here we're going to see a two sample t-test. Samples from the process before the change compared to samples of the process after the change. Is a failure rate acceptable? And so what we say is, here's my criteria for a failure rate acceptability. So for instance, if we're talking about warranty rate in the field and we've budgeted 1% failure rates over the lifetime of a project, We might say, okay, what is the failure rate compared to the installed base, and is it above or below that proportion that we have already budgeted? So that would be a one sample p-test or proportion test. Are each of the samples equally reliable or consistent? And here we'll take the two samples and compare the spread of the data in each of the samples, and we'll have a test of two variances. So we'll see that each of these different ways of evaluating tests has to be developed relative to the type of question we want to have in the real world, and we'll convert that into then a specific statistical test as we go further in our process. So we'll come back and we're going to talk more about this idea of hypothesis testing in our next video.